All right, guys, so the next thing that we're going to put into our notebook here is going to be a real quick little tidbit about, is your XY point going to be a solution on your graph? So we're going to say, is XY a solution? And that's going to be on page 23. All right, so is a point XY going to be a solution for your system of equations? So we'll flip on over to page 23. All right, and first thing that we're going to talk about, so is XY a solution? And the first thing we're going to talk about is the easiest way to do this is by just simply plugging in the values that they give you. So the given system is going to be y equals negative 2x. Oops. And y equals x plus 3. So these are already in y equals form, slope intercept form for us, which is great. But you can also do this type of calculation even if it's in standard form. So what the question is going to ask us is the point 0, 4 a solution? So we're going to figure out that one. And then we're going to do another one. Is the point 2, 5 a solution? All right, and so we'll test both of these out. Now, again, Desmos works great for systems of equations because all we really have to do is type in this to our Desmos, and we're looking for, remember, a solution is the point where the two equations or the two lines cross. So really what we would do here, if we have a calculator, plug these into Desmos and say, did it cross at 0, 4 or did it cross at 2, 5? And your answer could be no for both, but it could only be yes for one because we know two intersecting lines only cross at one point if they cross at all. So the other way to do this though, if you do not have a calculator, is to simply plug in your x and your y value. So our x value is 0, our y value is 4, so we have to test it for all of the equations in the system. So we're going to test it for the first one, and we're going to put in 4 equals negative 2 times 0, which is really going to give us 4 equals, well, negative 2 times 0 is 0, and that is not true. If it doesn't work for one, it can't work for both. So we can already tell that this is not a solution to our problem, but let's test the other one just for practice. So we're going to plug in y, which is 4, equals 0 plus 3, which really gives us 4 is equal to 3, and again, that did not work. But even if it worked for one of these, if it doesn't work for both, it cannot be a solution. So our answer here is no. All right, so we're going to do the same thing for our second example here, x and y, and we're going to plug it in. So we're using the same equations that were given, and we're going to plug in our y value is 5 equals negative 2 times x, which is 2. All right, and so that's really going to give us 5 is equal to negative 4. And again, that one is not going to work. So we can already determine that 2, 5 is not a solution. All right, test it out for the second one just to check. So our y value, 5, is equal to 2 plus 3. That gives us 5 equals 5. Okay, so this one worked. But again, if it doesn't work for both, then we have to say that the answer is no. This is not a solution. That would mean that this point would have to be on both this line and this line. Okay, and it doesn't work for both, so it's not the intersecting point. So the last one we're going to test is the point is negative 1, 2, a solution. So we're going to do the exact same thing. We're going to plug in our x and our y values. I always like to label. So y is 2 equals -2 times -1. Well, that gives us 2 equals 2. So far, this one looks like it could be a solution. So we do have to check our second point here, our second equation, by plugging in our point. So we have 2 equals -1 plus 3. And if we do that math, 2 equals 2. So that tells us that since both of these were correct, that this is the solution to our system of equations, which means that is the intersecting point there. All right, so that's going to be all for today. You guys are going to have 2 lessons on IXL. Those will be posted below. If you have any questions, please remember all you have to do is contact me on Remind 101 or through Google Classroom's app, or you can shoot me an email. All right, good luck today, guys.